This is problem number 4 on page 69. X plus y minus 1, parentheses, dx, plus 2x plus 2y minus 3, parentheses, dy equals to 0. So actually this is an example from lesson 8D, which is a solution of a differential equation in which the coefficients of dx and dy define parallel lines. Alright, well it's actually normally pretty easy to spot the parallel line situation. These coefficients are multiples. In other words, if I multiply this expression by 2, I get 2x plus 2y minus 2. Now the constant will disagree. If I multiply this by 2, it disagrees. So that means that the lines have the same slope, but they have different y-intercepts. So they run parallel. Running parallel, they do not intersect, so I can't use the method I just used on the previous video to find the point of intersection. So what do? Well, the book says, okay, well let u equal to, u is our favorite substitution variable. Let's let u equal to x plus y minus 1. And you can see that 2u is 2x plus 2y minus 2. And so if I were to subtract 1 from 2u, 2u minus 1 would be 2x plus 2y minus 3, which is this part. Okay, so I've got a substitution I can use here. This gives me u dx, right here, plus, parentheses, 2u minus 1 dy equal to 0. Alright, well, we're not out of the woods because now I've got 3 variables here, and that's not too good. So I need to substitute for x and y. And suppose we substitute for what? Y? Doesn't really matter, I don't think. I can substitute for x. So over here, x would equal to u minus y plus 1. So bring these to the left side. U minus y plus 1 is x. And I need to substitute for dx, so take the differential. Dx would be du minus dy. And then the differential 1 would be 0. Okay, so now I've got u, parentheses, substitute for dx, du minus dy, plus parentheses 2u minus 1 dy equals to 0. Alright, well, let's combine terms here. So I've got a 1 du term, so it's u du. Now I've got minus u dy, and then plus 2u dy. So the minus u and the plus 2u make it a plus u. So plus u, and then minus 1 dy equal to 0. So make sure you follow that algebra, okay? Skipping a step. U minus u dy plus 2u dy is plus u dy, and then minus 1 dy. Alright, so do we have a separable differential equation? Let's hope so. So I'm going to bring this to the right side. So u du equals to, when I subtract it, it would create a negative sign. When I distribute the negative, it reverses these. So I have 1 plus u. I'm sorry, 1 minus u. Then dy. Now that's it's very separable, because if I divide by 1 minus u, I've got a separated differential equation. So let me go up here, and I need to do what here? I better keep these substitutions. So going from this equation up to here, I've had u over 1 minus u du equals dy. How do you integrate that? Okay, well, let's do a substitution here. Let's use a little. What's my substitution variable? Let's use v. So I'm going to let v equal to my denominator, 1 minus u. And so to substitute for u, I've got to solve for u. U equals to 1 minus v. U equals to 1 minus v. Okay. And du will be minus dv. So when I go to substitute here, I end up with on top 1 minus v over v times negative dv equals dy. The right side was left unscathed. And one more. Let's go ahead and distribute that negative through there. And you'll see, if you're wondering why I did this substitution, you'll see why. So I distribute the negative through here. I've got v minus 1 over v dv equal to dy. Alright, what I wanted was, if I'm going to integrate this, I'd rather face an integral with a single term in the denominator than two. Because now when I solve this by integration, I can just divide the v into both terms. Up here, it wasn't easy to divide 1 minus u into those terms. It can be done, but you'd have to use long division of polynomials, which you probably want to get into. Alright, so if I distribute the v up here, v goes into v one time, I'm integrating 1 minus 1 over v dv equals to integral dy. And now it's very easy to integrate. I get a v minus natural log of v minus natural log v, absolute value, equals to y plus a constant. And now we have the lovely process of getting back to our original x's and y's. The v was 1 minus u, so this is 1 minus u, substituted here, minus natural log 1 minus u equals the y plus c. Then this 1 is going to be absorbed by the constant, and now I'm going to separate the logarithm from everything else so I can get rid of the logarithm. So let's see how that works.